Hello, everyone. Welcome to today's webinar on why a computer science degree still matters. So whether you are joining us live this morning or you're watching the recording afterwards, we want to start off by thanking you for taking the time to explore such an important and timely topic. It might be a topic that's been on your mind for a while or one that's just recently popped up, but either way, thank you for taking the time to join us. I'll start off with a very brief introduction of myself before we dive right into the good stuff. So, my name is Anna. I'm the Domestic Student Recruitment Officer here at the Lassonde School of Engineering, York University. I support students like you throughout the entire application and admission journey. And I really want to help you learn more about our programs so that you can find the best fit for you. Now, since you've joined us today, perhaps computer science may be one of those programs you are considering. Now, I'm very pleased to be joined by someone who brings deep knowledge and perspective to this conversation. With me this morning is Dr. and Professor Jackie Wang, an esteemed and multi-talented professor here at Lassonde. In just a moment, I'll invite Professor Wang to introduce himself and lead us into today's discussion on the foundations and future of computer science. But just before I do that, if you are joining us live today, I'd like to encourage you to submit any questions you may have in the Q&A throughout the webinar. We promise we'll try to do our very best to answer as many of them as possible following today's presentation. All right, and with that, without further ado, I'm pleased to turn things over to Professor Jackie Wang.
All right. Good morning, everybody. Again, thank you, Anna, for organizing the events. And to those of you who might be joining live or maybe listening to the recording maybe later, welcome. And then I know you, congratulations for getting the admission to Lassonde for CS. And you might still be debating whether you should really accept the offer. So my role over here is to give you a little bit more information for your decision. Of course, decision will be completely up to you. But let me just share with you about my personal experience and also perspective. I'll try to also limit my talk to be within 35 minutes. I do want to leave time for those of you who are here joining us live to ask me questions, anything you like. Of course, anything to do with academic, I'll be more than happy to answer. And if that's outside my expertise or outside my knowledge, I'm sure Anna will help over here. Okay, so let me just get started, right? So I got some slides, I got some notes I want to show to you, and also I got my Eclipse, like a programming tool running as well. I just want to show you some, give you more ideas about what it might be like if you do study at Lassonde, especially in the ECS department for your major. So the overall topic is to see why a computer science or software engineering degree will still matter. So I want to give you some idea about the fundamentals we want to teach you, and also get you experience and get sharper by the end of by the time you graduate, and also to talk about the mentorship you're going to get exposed to. I think that's really one of the most valuable thing you can get from in-person communication with us, and also about how you can get yourself ready in the future. Okay, let me just start with some slideshow and I'll switch to my iPad for some notes building. So what about myself? Very briefly, I actually graduated from York. So if you do accept to York, you will be like me. You'll become alumni for the university. I do personally think York is a fantastic place for you to actually do your undergraduate work, develop your intellectual readiness, and also resilience, for the future job. So I finished my undergrad at York in 2006, and then I went off to abroad to the UK to study my PhD in also computer science, specializing in software engineering in Oxford in the UK. I somehow didn't end up staying there after my graduation. I actually came back to do my postdoc, a little bit more research work, but more with the industrial collaboration. Especially I stayed between McMaster University in Hamilton and also the Ontario Power Generation. It's more like a safety critical domain that I work in for my research, a little bit more practical work. So I did it for about 3 years, and then I decided to maybe accumulate more international experience. So I decided to go abroad. I stay in Suning, Korea. It's in Korea, South Korea, but I kind of taught in English, just about compatible curriculum to like a state university of New York. They have an international campus there. I taught all the foundational courses in those 2 years in Korea. And then in 2017, I came back, becoming a teaching faculty here at York. And then there we go. So I've been here for less than 10 years, but I do know the campus around. I do know about our curriculum, and also I've been learning with many of your earlier fellow students. So if you really have questions about what the experience is about, I will give you some references later, okay, as well. Right, of course, that's where I am right now. Okay, so what about the experience in Lausanne? So the part I want to really focus on today will be you're going to build the foundation through a pipeline of courses. You're going to get conventional lectures in person and also tutorial as well. Tutorial can be run by the TA or can be run by your professor. I want to just talk about this pipeline very quickly, just to give you a little bit more idea about the sequence. So this part over here is about the pipeline of foundational courses, not entirely, just a little bit selective view. These are the courses I have been teaching in Lausanne, actually over the past 7 to 8 years. So for you as a CS major, you will do as a second course in your first year, 1022, the introduction to object-oriented programming in Java. And then your second year, you're going to start with some advanced OOP also in Java. And then you run into, we call the interview courses. We want to get you prepared maybe for the technical interview for either the local companies or maybe for the very prestigious high-tech company like Google, Facebook, etc. Right? So we're going to teach you about data structures and also algorithm. I'll talk more about like individual courses, what will be the design philosophy behind the courses. And then you get to the more advanced level of software design. You want to see how you can manage your software in large, especially in these days, even though you got AI, I think maybe some portion of your software might be automated, maybe generated by AI, but still a large portion will still be up to your foundation, how solid your foundation is, and how creative you are. Software design, and also I also get involved in the software engineering curriculum, so we also teach students about formal specification and also mission critical systems. So these courses, conventionally, they are more mathematics heavy, but I'm going to argue later in my presentation, even in the age of AI, these formal skills become even more important for you to leverage the AI both efficiently and also reliably. And also a course which I will hope to give you just some idea. So this will be the ultimate course in the CS called Compilers and Interpreters. It's elective, but you can also choose it to really try to synthesize all the skills you have learned in the previous foundational skills over there, right? So that's you definitely got lots of many other courses maybe natural science, social science, or maybe other if you want to study maybe Chinese, for example, as elective. There are many other things you can get in addition to the core. Right, but for today, I'm going to focus more on the core. Okay, let me just go back to the slides and then you move on. So the main principle in Lausanne is really learn by doing. We really want you to build the experiential ability. We want to learn by experiencing about how the code development can be undergone and also how you can do testing, debugging, etc. You will be given projects, depending on the courses, you might be given projects, but many courses will definitely give you some labs for you to practice. You definitely get instructions, you get time to struggle, you can get help. You can also discuss with your colleagues, discuss with TA, discuss with a professor, and after that, you will be also assessed about how well you have internalized your the skill and knowledge. So there could be some very conventional paper and pen test, like an exam, or it could be multiple choice. It could be some in-lab programming test that you might be required by your professor. So you have to sit in the computer lab. You will be invigilated by TAs, and also you have to show that you are able to reproduce software developments within some time constraints. So that very nicely mimic about how you will actually have to go through some technical interview. Well, later on, if you work in the industry, you will have to go under pressure constantly. So that's something we want you to really get experience and also get adapted to. And also, definitely, you will get feedback, right? You can get a feedback from when you get your marks. You can also even approach your professor for maybe further feedback if you want to. You just gotta stay proactive to about your learning. And you practice lots of skills in all the foundational courses, the ones I kind of listed right in the previous diagram there. So you're going to learn about programming, testing, and also debugging, and also about mathematical reasoning And also you're able to show that, for example, you've given some AI output. Are you able to reason that the output is indeed not really hallucinated? It's also not fabricated. You're able to reason about it. And also you're able to communicate about your idea. So all these sort of soft skills you want to be able to develop by some in-person learning throughout your degree. Okay. And you get also all sorts of support from Lausanne and also from the EEC department. You get office hour from your professors and also TA. You'll also get some mentorship. So let's say maybe in the summer term, if you're interested in not just taking courses, you want to get some research done, you want to get some TA, teaching assistantship done, you can definitely reach out to your professor. They might be able to offer you some either paid or unpaid part-time opportunity. That's really a good way to really add to your CV and also add to your skill box. Okay. And also, definitely, you got lots of communities there. Sports club, maybe more club about coding, club about AI, etc. You can definitely reach out and also build your connections. Right? The experience Lausanne is definitely a promising one. You can definitely get lots of support and also lots of skills that you can build throughout the 3 or 4 years of your degree. So I want to give you guys just a very quick live demo just about how you can expect like a university lecture can be. Of course, I have my own teaching style. My other teaching colleagues, they might have their own style, but just want to give you some idea, right? That's definitely something you want to get used to, and also you can take advantage of from maybe the expertise of your future professor. So what I want to do is something I normally do in the more advanced object-oriented programming course, just to especially in the review part when I want to walk students through about some ideas they have learned earlier. So let me just take this example here about calculating the body mass index. I'll remind you about the formula. You may have seen that before. Okay, maybe in your high school, maybe earlier. But this is a pattern that's not just going to be applicable to BMI, but it's actually a very abstract, like a very general reasoning pattern we can also apply to other more safety critical domain. That's something I just want to mention. Okay, let me give you some idea here. Okay. Oh, by the way, so this part here just about AI. I'll get to it a little bit later in the slides. Okay, let's take a look at here. Okay. So what we have some Java classes. I already got it loaded up on the Eclipse. We can look at the coding as well. Okay. So let's say a person is characterized by their weights and heights. They're simply double, like a fractional number. For example, it could be 72.6 for their weights and 182, let's say 1.82 for meters for their heights, right? So we got different attributes. And also we got a constructor for creating a new person instance by passing the weights and heights. And also, we are able to calculate the BMI for each person. Oh, by the way, if you're not familiar with Java, that's no problem. If you can somehow just get an idea, right? So I'm going to walk through some logic with you. So to calculate the BMI, so we're going to use the following formula. So BMI will be equal to the weights divided by the square of heights. So that's why you will see exactly right here in the programming. Okay, just reflecting the formula. And then we are able to say a person, they might have already grown their weights by certain kilograms. That's also realistic. Okay, so that's kind of a very simple Java class we have for a single person. Okay, and then so this will be another fragment of code which we'll try to test. We'll try to use the the person class that we have just created. Right? Let me just walk you through about the idea. So we have two objects we are creating, Alan and Tom. Let's say these are the two persons. So Alan has the weight 72 versus 65 for Tom. Alan has the height 1.72 meters versus 1.81 for Tom, right? So different persons. And then we simply want to print out what's the BMI for Alan and what's the BMI for Tom. Apparently, it should be calculated based on these two pairs of numbers. They should be different numbers as far as we can know, right? We don't need to worry about what exactly will be the numbers. And after we have done this, we're trying to do some line over here. Let me just highlight it. It will turn out to be very critical, but let me just highlight it for now. Okay. So this will be a line that we don't necessarily just know just yet. That's kind of the point for the review, right? Let's say we do some line of execution right here. Let's talk about this. So here we got Alan right here. And we say Alan is going to gain his weights by 3 kilograms. So you would think if the weights will actually go up according to the formula, the BMI over here, because the weight will go up, the BMI should also go up. That's obvious, right? That's something we know. So as far as Alan is concerned, we should really expect his BMI to really go up. On the other hand, since we know Alan is the only person who's gaining the weight by 3, what about Tom, the other person? So Tom should really stay the same for his BMI right here. Right? Let me summarize the kind of the predictions we have, if you can agree with me. Number one, for Alan, he is the only person who has grown the weights. So that means his BMI should really increase from some number to another number should increase. On the other hand, for Tom, the second person, since he was not part of the person gaining the weights, so in that way, his weight should really remain the same. So this number and this number should be equal, right? So these are the two observations. So for us as a scientist, we can look at the program here and then make some prediction based on our judgment, right? But after all, we have to really use some real execution to prove our points. So that's something I want to go over with you. So if I switch to programming tool, so this will be something you also will get to see a lot in your many courses in Java, because in ECS, our teaching language, in many cases it will just be Java. So this is a tool called Eclipse. If you are used to other tools like maybe VS Code or maybe IntelliJ, similar look and feel. So what we have seen so far is we have the source package, and then we got person. So that's the class I just went over with you, the same. And also the person tester, also the same class, right? All we want to make sure is, will Alan increase his BMI? And also, will Tom actually remain his BMI? That's our question, right? So if I actually execute the code, that's what I will see. You can see Alan, rather than increasing his BMI, he has decreased. Also, Tom, here, rather than maintaining to be the same BMI, it actually increased. It seems like our prediction was totally wrong, right? So this is the kind of a point that we should really maybe revisit our judgment before and then try to see if we can reason about it. That's really the skills that we are trying to build into your foundation, right? Let me just go over quickly with you just to see the reasoning, okay? So whenever you talk about object-oriented programming, you always need to visualize and try to trace the code to see how each line is going to have the impact on the relevant variables and also objects. So the output we just have confirmed from Eclipse goes like this. You can see right here, if I look at Alan here, it will actually decrease. And also if I look at Tom's BMI from here to here, it actually stayed the same. Totally opposite or totally different from our prediction. But now we're going to see how we can reason about this, right? Let me also go very quickly to revisit the line. So here for line number 1, right here. So what we want to do is we want to create this Alan object here with 72 and also 1.72. So we got Alan. It will correspond to this object here. And then we got 72 and also 1.72. And we got the second object here, Tom. So that'll be second. It will be 65 and 1.81. So 65 and 1.81. So that will be Tom. So the numbers we have seen over here, they are individually correct. You can think about this number here will just be based on these two numbers. And this BMI result will just be based on these two numbers. So we are good. So now we need to understand why, after gaining the weights, we wouldn't get the result as we predicted about a trend of increasing or decreasing or staying the same. So we're going to understand exactly this point, right? This line here. So this line here, in the review, we will actually say this illustrates exactly the phenomenon called reference aliasing. I wouldn't get deep into it, but what it is saying is we are actually going to let two arrows pointing to the same object. That's exactly what the equal sign will do. So we are saying that we want to change Alan, and we want to change that to wherever Tom is pointing to. That's what the equal sign means. So Alan, rather than pointing to here, is going to point to wherever Tom is pointing to, right here. Right? So once we have got to this point here, both get BMI. Calculation over here, doesn't matter if you use Alan or Tom, you are still using the same, right? Now you can see that both are pointing to the same object. So we are really using the same pair of number to calculate the BMI, right? That's exactly what's happening in the eclipse. And this is a very common confusing scenario that your fellow student early in my previous classes might get confused. And that's why usually in the university classroom, this will be the kind of example you want to pay attention to and also try to follow along with your instructor, right? So I just want to give you one example here. Okay. Of course, depending on the nature of the course, sometimes it could be more vivid code tracing, and sometimes it could be something about deriving some theorems or maybe conducting some proofs. So these are all sorts of different tools we want to build into your box. So later on, you will be able to deal with the like a creative scenarios that'll challenge you. Okay. All right, so that's about the demo I want to do. And then I want to spend maybe the next 15 minutes or so just to go a little bit more about some ideas about AI, maybe about the more detail about what kind of experience you can also expect in the song. Okay, let me just move on. So AI is really everywhere. And we know that AI can really automate many routine tasks. I can even tell you there are many questions in your lab or many questions in your projects. You might just be able to get some initial solution just by asking the AI. That's definitely your judgment call. However, it may not be so beneficial for you as a long term. We want to understand the distinction here. For routine tasks, AI can definitely help, but in your future challenges, most likely they may not be restricted just to routine tasks. You might be expected to solve many things that's maybe something you haven't really seen before, or maybe something that's beyond routine. You will definitely need a foundational skill to help you construct the actual like a novel solution to it. That one is something you cannot just rely on AI. That's a really critical point I want to make. Okay, let me go over some points over here, and then I can go back to the diagram and give you some conceptual sketch. It is important to realize AI, they are not perfect, for sure. Doesn't matter which tools you're using. You might be using ChatGPT, Claude, DeepSeek, or maybe Gamma 9, right? So different tools. They can hallucinate, they can fabricate, they can misinterpret, they can also overlook. So these are known facts about AI. So whatever output you are receiving from the AI, so these shortcomings are always possible. So where will be your judgment to really see that? So these shortcomings are really present. So that's why you need a foundation. Okay, let me just go a little bit further into sketching a little bit more. Okay, so let's look at right here. Okay, so you can now just focus on the bottom part right here. Right, can you focus on this diagram over here? Just go a little bit more about the idea. Just to start with, we know that we have some AI tool. It's more like a black box to us. We don't know exactly how how the intelligence works. We don't need to as a user. So we got AI tool right here. And of course, it could be more than one tools you're using. Maybe you want to have a combination between Claude and also ChatGPT, right? You can definitely get multiple tools that you're using. And in order for the AI to really generate some output for you, you will need to supply some input. Okay, let me use a different color here. So you definitely got inputs, or to be more precise, you have to give some prompts to the AI. Okay, and the AI, according to your prompts, however good it is, it's going to generate some outputs. And output, a very typical shape will be just code, software code. It could be in Java, could be in C, could be in Python, whatever you specify the AI tool to really generates. Okay, before I be a little bit more critical about input and output here, let's also look at the other end of the story. So far, this part of the domain or this part of the world is more about routine, something that AI, based on their training model, they can easily tell you what the solution should be. Okay, so this part here will be routine, or sometimes it could be a combination of different routines, maybe like a novel combination. That's also possible. But the other end of the world, which you will see more often, will be something that's more creative. And creative could be just two examples. It could be something about you want to maintenance. You want to maintain, maybe try to maintain the internal workings of your software, where your software has many independent modules working together, right? Of course, here I'm just underspecifying. So in reality, it could be tens or hundreds of modules working together realistically, right? I'm just drawing a few just for you to get an idea. Maintenance, or could be for extensions. So all these purposes definitely require something that's beyond the routine that AI can just help you and just give you the right solution. It's not really there just yet. Okay. So you can think about whatever that's generated by the AI, there will be some output over here, and the output may somehow just correspond to. You can think about this that's generated by AI is being used as one of the module in your software projects. So now we want to be critical. Is this AI generated unit can really be compatible, or they can then really work well correctly with the rest of your with your software project? Maybe other parts are developed by either yourself manually, or other parts are developed by other teammates in your software team. So we want to ask this critical question: is this output really good enough for us to rely on? That's a critical question. So let me go a little bit deeper. So let's talk about the input right here. So the output of the generated code can only be as good as your inputs, really. So what kind of prompts are you giving to the AI, right? So the criteria will be, number one, how precise is your input? Maybe you're just being ambiguous and AI simply didn't know how to interpret your intents. So gotta be precise. And also it has to be complete. Have you really included all the assumptions, also any constraint or all the input scenario that AI should really consider when they generate the code? That's also very important. Otherwise, there may be some missing cases or simply some scenario that you really don't mean to occur when the generated code is run. Okay, and also, yeah, of course, assumptions over here is also very important. And now for the output. This will be very critical for you to definitely to think about, right? Over here, whatever output you're getting back from AI, you shouldn't the last thing you want to do is to really take it for granted to assume it's going to work 100%, especially in the more safety critical or maybe more serious domain. Let's say if you're really doing this before you can actually commit to the software project for everybody else to rely on. You definitely don't want to just take whatever that's generated by ChatGPT and then simply commit it to your team. That's not the way to go. So to really ensure the quality, you ought to do at least one of the two things. Number one, you may have to test it, test the output. But in order to test it, you ought to know what's the strategy for you to really test the output. And also, number two, you may want to do something a little bit more formal. You may want to do some proofs as well, right? So these two skills about how to ensure the quality of the output and also how to make sure the input to the AI are also good enough for the AI to really generate something that's as correct as possible. So these are all depend on your foundational skills that we hope to train you on, right? You can think about as the AI gets more and more popular, all these skills are just more and more demanded on you, right? So that's really another point I want to make. Let me go back here. Okay, so what's really opportunity here? So as AI actually gets more and more popular in generating the routine stuff, we want to make sure you're able to evaluate and you're able to combine the AI output with some other output as well. So you really want to have that foundation to really deal with such challenges. So fundamentals, they are now even more valuable if you want to leverage the AI both effectively and also responsibly, right? So you want to think about that big picture I just drew to you over here. That's a very important sketch about how you can think about how AI can be integrated into your professional task later. Okay. And then, so I think that's pretty much all the points I want to mention, but I think now I just want to give you more details for the maybe for the next 10 minutes. Okay. So AI, they may produce the code that might looks right, they might look plausible. However, you never know until you really test them. So you want to make sure you can state the requirements precisely when you prompt the AI to generate something for you. And also you want to, once you get a output, you want to also validate the assumption and constraint for your development. You want to make sure those constraints and assumptions are really encoded in the generated code. And also you want to be able to test the edge cases. And what will be the edge cases? It will be you to actually figure out what the edge cases are. And you should only accept the AI output and use it maybe for the rest of your software project if you are pretty sure it is correct and also safe. And you can only have such conclusion if you're able to test it and also to prove it. Okay. So professional judgment is definitely still very important. It gets even more important when the AI might just be part of your tool. So these are the things you definitely cannot really replace just by saying, I'm just going to use ChatGPT to generate everything for me. It's not going to work in the long term. Okay. And then AI, it can definitely give you some shortcut because many of the routine tasks, you might just get the answer from them. However, it might actually give you some we call cognitive depth in the long term. Because if you simply replace all your basic understanding about foundations just by generating everything from AI, it's actually not going to do you a good service in the long term. So you want to really make sure for all the future maintenance and also extensions that might require more creativity, you're able to actually tackle them. In order to tackle them, you must know the foundations well. If all the routine tasks are just generated by AI without understanding them, you're not going to be able to do extension and also maintenance. Okay, so we're gonna focus on. Of course, these are just the terms. I want to just give you more like a checklist. The list is definitely not exhaustive, so these are just some of the most important concept we're gonna train you over the years. Abstraction, logic, regression testing simply means you want to keep testing the output whenever you make any changes. You want to make sure your output is always maintained to be correct, and also debugging fluency. So if you actually got any test failure based on your software testing, you want to be able to debug where exactly goes wrong in your software code, either the code written by you or the code generated by AI. You want to be able to debug and also fix them whenever you have to. And when you do reasoning, you also want to be able to do it independently. So we need to make some judgment call to see whether the output is acceptable. Okay. And in Lassonde, of course, in all the EECS courses, we definitely want to give you assignments, give you the labs, so you can build a mastery of the required foundational skills. And also, we want to make sure that you're able to actually reproduce all the reasoning independently. So we'll definitely give you some in-lab tests. So we got very good in like a lab infrastructure in Lausanne. Maybe for those of you who actually came to the spring open house events, you would have seen our really small center labs. So we definitely got very good infrastructure to really test you just on how internalized you are about the required skills and knowledge. All right, so definitely you want to make sure the understanding is something you will have to build, not just by using AI to generate the code for you. It's not going to be just that. Okay. All right, just give you a little bit broader context here. So let's say beyond your graduation. So maybe you're from the CS, even though you might be just from the CS major, but maybe you want to get involved in the more serious and more safety critical or mission critical work. Maybe you want to work in the nuclear industry or maybe automobile industry. So those industry are kind of they will require you some professional license. Okay, so this is something I'll give you one slide, just something you can think about. So for professional engineers, the in Canada, each province will be responsible for issuing licenses to its professional engineers. So in Ontario, we have the PEO, like a Professional Engineers Ontario. It's the society that will issue the licenses. For myself, like you, I actually got a CS degree. So I didn't really get a full license, but for the purpose of professional teaching and also research, I got my limited license, which is good enough for the purpose. But for those of you who want to go even further, you may want to want to get a professional license. So they have this code of ethics. I'm not going to read it off, but it's just about the expectation we have on the professional engineers. And for one of the criteria there, especially for number 4 and number 5, it's about knowledge and competence. It's about if you know all the tools that are available to you in the box for you to solve the problems. And that will definitely rely on how solid you are in the foundation. And number 5 is about competence. Knowing that this maybe tool X might be the best solution, are you able to build something that will just work like a solution X? So that's why we want to give you in-lab programming tests to make sure you're able to really build something foundational from scratch. That's definitely a very important skill. So knowledge and competence is something you want to really focus on in your degree. And let's say you're involved, let's say building a bridge, or maybe just in the software part for the bridge. When the bridge is actually put into use, you actually have to sign your name on the certificate to say, me, Jackie Wang, now I'm certified that based on my expertise, I think the bridge should be fit for use. But what if the bridge collapse maybe many years from now? In that case, I will definitely be held responsible. So there might be different consequences for what they call the misconduct for your professional engineering. So it could be, if you're lucky, you might just get maybe suspended or terminated for your license because there might be some financial loss involved in the collapse. But if there are human lives involved in the failure, then you might just have to go under some lawsuits. So definitely you want to make sure if you're really interested in doing something much more professional, much more serious, you definitely have to consider building a very solid foundation throughout your degree. Okay, I just included some link over here just about PEO. You can definitely take a look if you're interested. Okay. This one here, I'm just going to spend 1 minute maximum. So one of the courses I mentioned earlier, just about compiler over here, 4302. Typically, you will take that at the end of your third year or maybe the beginning of fourth year in the towards the final stage of your degree. Given that you have already learned about all the foundations right here, so you can take one that will synthesize everything together. So you can think about this very like a big project course where we're gonna review certain foundations, theoretical foundations, and give you your opportunity to work on some very substantial projects. Maybe teamwork. You can definitely also practice your communication skill with your fellow student as well, and write some professional report and give some presentation as well. All right, so let's give you some quick idea, just 1 minute. So compiler is simply a software system you have to implement automatically that will translate from one thing into another. So this is a very high level view. You have to go from one input into another output. Think about a compiler here is some black box that you as a compiler builder, you have to implement everything here from scratch. Part of it might be with the help maybe from ChatGPT, but again, you cannot expect ChatGPT to generate everything for you. It's not realistic. You might have to only use, you have to still build many parts by yourself and then be responsible about which part you want to use a ChatGPT or generative AI. Okay. And there in the industry, there are people, you will see some compiler maybe to go from Java program to SQL databases, or maybe the more conventional use from some program into maybe assembly instructions. But don't worry, you may have not seen all these concepts just yet, but you will see them gradually in your CS degree. So that's why this course here is so valuable. There's so many things you have learned throughout the 3 years, and you can just use them and try to apply them in this single course. Okay, and of course, it's gonna require many theoretical actually knowledge as well. For example, just CFG. Don't worry, it's something you will also learn when you get exposed to the theory of computation. So these are all the stuff you're gonna see in your degree. And finally, so this will be just again, it's not exhaustive. The compiler course is also one course where you can see many principles about software engineering or software design you learn on the paper. Now you have a chance to really apply them to, excuse me, you can also apply them to your projects in this course. Right. All right, let me just start wrapping up so we can definitely take your questions, right? I'm saying I still got a few minutes and then we're done. Okay. So for the next wave, it may be AI heavy or maybe something else. We simply don't know. However, I think our safest bet when we are facing uncertainty, let's now make sure the foundations are solid. I think the foundation should always be there. Doesn't matter what the future might demand on you. So we got to make sure we got solid foundations, we got practice skill, and also resilience. That's actually also very important. When you're tackling challenges, we know you might have maybe multiple attempts, and some attempt might just be like a failure. You want to be resilient enough to keep trying. So the school is actually a very nice environment for you to feel safe. So maybe you didn't do so well on a particular lab test. Maybe you didn't do so well even in a single course, but you can always, try to regroup yourself and try to reflect and try to do better next time. So this is really some mindset we want you to have also before you graduate. It's okay to fail, but you actually have to learn why you fail and try to not fail for the same reason again. So future ready. So we want you to not just be a user who uses AI. We want you to be someone who can supervise. That's so important. You want to know the big picture. You also want to know the details for individual technical components, and you're able to assess how good quality the AI generated component is. Okay. All right. So final slides right here. All right. Just about beyond the courses, you definitely will get chances to get mentored by your professors or other staff members. And also, you can build connections to your fellow students, to professors like me, or maybe TAs, and also other research group, and also industrial mentors if you do maybe some internship or maybe co-op. And what will be the opportunities? There are tons of opportunities for sure. So you could be, if you're more interested in doing academic research, there could be some maybe like a full-time opportunity, like a research competition in Lausanne, and also maybe some part-time opportunity, maybe in the fall or winter, if your professor needs some help, maybe from some brilliant minds like you. And also you can get into maybe more about industrial opportunity like a co-op or internship. But let's say if it's in their nature, they're very competitive. But you can also sign up maybe for project courses. For example, for the compiler course, well, maybe there's also the EECS 4080 Computer Science Research Project course you can also sign up for. You can get some credits. At the same time, you can build something substantial that can also add some value to your CV as well. All right, so finally, the path after your graduation, you can also start thinking about. I know you got a long way to go, but it doesn't hurt to think about in the beginning. Do I tend to go more into industry or maybe academia? Maybe like me, you maybe like a teaching, you like a doing research. You can think about which path you may want to go. Accordingly, you can think about how you may want to prioritize the your time and also energy, throughout your degree. You definitely got lots of opportunities for sure to help you grow and learn. All right, I think that'll be it. In the end, I just want to thank you, everybody, for listening. And also, if there's any question, I will definitely be happy to answer. I want to show you two quick references. So, for me, I have recorded all my lectures ever since I joined York. So you can definitely follow this link here. I'll show you. There are two links over here. I'll show you quickly, and then I'll hand it to Anna. Okay. So this one site here is public domain. You definitely don't need any logging. You can already take a look. If you're kind of curious about what kind of classroom experience you can have from the foundational courses, you can see I got all the courses I kind of mentioned in the previous pipeline diagram. You can take a look. I got all the lecture recording and then some practice questions, some notes, some slides there. You can definitely take a look. If they are all free educational resources for you to take a look. And also, this is an open letter I try to start writing to my students for every semester. I just want to give them some idea about how they are supposed to align with expectation on the foundational courses. You can also take a look. You can definitely find a link on the slide as well. All right, I'll stop here. Over to you, Anna.
Thank you so much, Professor Wang. Now, as promised, we are going to turn it over to the Q&A and see what questions our audience has for us today. I see here there are already a few questions, all very helpful, especially for prospective students. The first one being, has there been any noticeable differences in co-op applications or offers within computer science students over the past years during the rise of AI? Fantastic question. Now, of course, co-op is an opportunity that is available to all of Lassonde students as long as you want it, right? So it is not mandatory, but it is optional for all of our students. For all of our students, and in fact, a number of our computer science students are interested in co-op. And I'll turn it over to Professor Wang if he has any, additions to make to this. But I do want to share in the Q&A here a web page that our co-op team puts together at the end of each academic session. So this one right now currently posted, it's for the 2025 school year. So it is still relatively recent. You'll be able to see essentially co-op terms, co-op opportunities in the form of numbers and stats. So you can see essentially the average wage, the number of co-op terms our students have gone on. Now, of course, all these numbers may seem arbitrary to you. You don't know what they mean yet. You don't know perhaps the size of the cohort that you will be joining just yet. But hopefully it can provide some reassurance for you. I think there is some and some of it is true. Yeah, I'm sure that you've seen in the news some layoffs, some tech companies, cutting down, trimming the fat, if you will. But that doesn't necessarily mean that computer science students or other computing degree students aren't still in demand, right? As Professor Wang has touched upon, with the rise of AI, with the emergence of these tools, the demand just shifts for this towards students or I guess professionals who know how to use different skills to integrate AI into their work. So you can continue to see that co-op opportunities, different industries are still offering opportunities. Perhaps we just need to shift our mindset as to how, um, I guess, computing degrees are used or the types of opportunities that are available. In short, the answer is the numbers still support that computer science is still our largest program. It is still in demand from students, and you can see that our students are still finding co-op opportunities, and then of course through that later on opportunities within the industry. I don't know if Professor Wang, you have any insights into this or your conversations with students.
Right. So
Mhm.
in terms of finding co-op, of course, I think it's definitely competitive. Based on what I learned from my former students, I think maybe before you even apply for co-op, you may want to speak to maybe as many of your fellow students, especially at the more senior level, your fellow student, to see what their experience might be. As far as I know, sometimes they might have no luck, maybe through the more official connection, which is normal, right? Because if that's about competition or competitive, it's no guarantee. So you may just want to see there's any connection you can really
Mhm.
being referred to in the company. Also, another one to really think about as well. Maybe it's not exactly AI in the industry, or maybe AI in academia, or maybe AI research. So for co-op, you don't necessarily have to work in the industry to get counted. So I forgot the exact number. Maybe it's about 300 something, but
Mhm.
Anna can correct me later, but it's about that many hours. If you can find some faculty who's willing to support you financially in the summer, you can actually work as a full-time, like a research assistant. So I was supervising actually two of my students, co-supervising with my other colleague, right? So we kind of pay them as a full-time researcher, but they're doing the more pedagogical research to help us build experiential lab. Of course, the project that you will do will be completely up to the agreement between you and your supervisor. If you're really interested in doing AI, you can ask them if there might be any project you can do during the summer to develop something serious, either practical or theoretical. And at the same time, you can count those hours for co-op. Right. Of course, there will be some details you have to look into as well. But I think in general, you don't necessarily have to only get AI experience just from co-op. You can also do from school as well.
That's such a good point. I think sometimes um, we will even kind of narrow down our own scope because we think of co-op being, one path, but there are so many other opportunities, like you mentioned, through networking as well. So whether it's networking with your peers, networking with your professors, who are also many of them are industry experts, right? They're your mentors, like you mentioned earlier. So chatting and having good rapport with your instructors could also lead to other opportunities and actually leads into the second question here in the Q&A. Especially for first year students, do you think it's more difficult for them to get research or those kind of paid opportunities? Or what advice would you have for first year students to get them started?
Right. I think for research, it would be definitely a little bit more difficult,
Mhm.
naturally, because in the first year, you would have only taken some very like a beginner or introductory courses to the subjects. And usually when you want to do serious research, you definitely will assume certain solid foundation skills for sure. So I would say maybe the more appropriate time for you to start finding for research opportunity will be maybe around the second semester of your second year. That's actually what happened to my former student who actually was doing some pedagogical research with me. So I can give you maybe it's a very concrete timeline. I would say in your first year and also for your second year as well, you want to make sure you focus more on learning and you don't want to be too much about marks driven. That's something I also want to say to my, I know realistically GPA is so important, but think about want to focus on learning to make sure you do things, not just those that will be associated with some marks. You want to do always go beyond what your professor might be asking to make sure you can learn as much as you can. I do believe, at least from my experience, if you focus more on the learning, and I think your GPA, the good result, might just follow. But you can definitely experiment yourself. So my point is, try to get your GPA as ideal as possible, and then I think every year they have the RURA and USRA research competition, which will fund you actually in the summer. Of course, if you can get one of those prestigious research award, that'll be awesome. If no, you can also maybe try to maybe reach out to your professor to see if there's any project opportunity as well. But I don't think just immediately after your first year, you will be exactly eligible for that just yet. Not yet. I think maybe you want to focus more maybe on getting your learning maybe solid, and then starting from your maybe second and third year, you can now start looking for opportunities. Yeah.
Fantastic. Um, Now we have another student who's thinking really far ahead, so well beyond first year. They're wondering if they choose to study computer science at the undergraduate level, would they be able to, let's say, apply to a master's degree in like engineering later on? Would they be limited by the computer science degree because maybe it's not an engineering degree, right? So in your experience or in your
Yeah.
perspective, what do you think?
It's a very good question. I think
Hmm.
at least it wouldn't be straightforward for sure. Let's say,
Hmm.
for example, for me, I I got my first degree in CS, and then
Hmm.
my PhD was also in CS, even though it has more specialization in the software engineering. But I would say it depends on how close the disciplines are. Uh, I think but of course, that's something you will have to look in more detail depending on the school as well. But I would say if given that at the time you want to apply for maybe let's say you got your CS degree and then you want to apply for maybe electrical engineering, let's say, or computer engineering, slightly closer. So I think the graduate school, they wouldn't just give you like a straight refusal, not necessarily. If you got very good GPA, you got very good experience, maybe in co-op, maybe so that means your co-op opportunity, you may want to find something more to do with hardware, not just purely software. That's one thing. And also they will look at your GPA, they'll look at your experience, and they will look at your reference letter to actually judge what your potential how good your potential is to really go with the degree. But I do believe you if somehow the record shows that you're very good and put has a very a student with a very good potential, they might just ask you to take some extra courses to actually fill the gap, right? So, but of course, the most ideal, if you really think you might want to go for like a graduate school, maybe not exactly like a CS, you may want to think about this sort of issues first before you actually get to before it's too late. Yeah.
Hmm. And there are resources available to you as we're kind of exploring these opportunities. Even if right now at the admission stage, maybe it's too early for you to decide what you're going to do in graduate school, that's okay. In fact, that's very normal. Kudos to you for thinking ahead, but at the same time, don't overwhelm yourself by maybe being too ahead of yourself. As you get there, as you're making those decisions, you have mentors in your program, you have upper year students, you have academic advising, career services, all available to you as a student, right? So even if it's within first year, second year, upper years that you're starting to think ahead, you can always seek the extra help, support that you need. But fantastic question either way. And really nice to see students kind of thinking ahead and looking at, the big picture here. Um, and then maybe one final question here in the chat. Um, Well, first off, the student has found this session very engaging and has found Professor Wang a very fun and sharp professor. And the student is wondering how relevant is Java in the industry today? And why is there such a focus in your courses on Java compared to, say, C, C++, or Python? And what exactly is the use of compilers with professional tasks?
Right, right. It's
So,
a very fair question. Absolutely.
mhm,
I can tell you that historically, this department, because I think we used to use a language called Pascal. Maybe I'm not, maybe you're too young to hear about it, but I think bottom line, pedagogically, it doesn't really matter like how we teach the foundational courses. We can teach in C, we can teach in C++, we can teach in C Sharp or Python. In fact, in the diagram over here in 1022, the course that goes before that is going to be the very first course you will take is a major. You will either take 1012 that's going to teach you about JavaScript, about how you can do web programming, or you will teach 1015, which will be about Python. Right. So you can see we do have a very like a variety of languages that in the beginning for you to kind of choose, like how you can build some very like an introductory, like a proficiency. But in terms of Java, just historically, we have been using Java in the curriculum. And also, I don't really have the website with me, but I think you can easily just Google to see the what's the most commonly used languages in the industry. I'm pretty sure Java is still one of the heads. May not be the most popular one, but it's reasonably popular. So when you graduate from this degree with lots of proficiency in Java, it's definitely not going to be wasted. But the most important thing is we are scientists or we are engineers. So it doesn't quite matter how you train your foundation in what language. Let's say I've been learning all the concept in Java. Let's say my workplace demand I need to do things in C Sharp or C++. It shouldn't take me more than a month or 2 months to really get myself trained, either by the company or by myself to really get used to the syntax because all the ideas we learn in the foundation are transferable. So it doesn't really matter what languages you're using. And as for the compiler course, that's another good pointer over there. So in 4302, since I know my students have been taking Java courses, I don't want them to really get any extra training, even though I could ask them to do it, but I just use Java. But once you learn about how to build compiler, you definitely can build compiler using a different language. You can use maybe Python. You can even use Haskell. If you heard about it, it's like a functional programming language, also quite popular in the industry. So I would say languages themselves are not really are really just a tool for you to get things manipulated, get things running, get things to show that it's working. But ideas behind this, the underlying ideas are really language independent. Yeah.
thank you. I hope that answered most, if not all, of your questions today, everyone. These are just such thoughtful questions, and I'm sure that other students who are either watching live or watching on demand later will find them helpful. Um, I just want to say, as we are coming to the end of today's webinar, um, we hope that the discussion doesn't stop here. We know that maybe you'll have more questions later on, or you're still making some decisions, or maybe today's discussion has prompted more questions for you, and that's all okay. And in fact, we encourage it. We invite you to take part in other opportunities to learn more about our programs, to learn more about our school, to get to know your peers. So please feel free to join us on future tours. Join us in Discord where you can chat with current students in your programs, upper year students that Professor Wang had referred to earlier on, and also get peer support. I'm sure that questions you have now, they've had when they were in your shoes earlier on, or maybe they're still thinking about in the upper years, right? I'll post all of those links in the chat there for you. And also, of course, we invite you to participate in future sessions similar to today's webinar. So I'll just put all of that in the chat for you so that you can bookmark them, you can click into them and view at your convenience. And if you are interested in rewatching today's webinar, that will also be made available on our Discovery Days website, which I put in the chat there for you. All right. Thank you all so much for joining today's webinar. Thank you, Professor Wang, for taking time out of your day to host this really helpful, really informative session for us. And again, we hope that this has helped you in your decision-making process, has helped you in your future planning, and has helped you gain confidence in your, decision to pursue a degree in computing. You can see all the opportunities, all the impacts that you can make with your degree in the future. Well, with that being said, I hope you all enjoy the rest of your day. And Professor Wang and I hope to see you at
Yeah.
Lasan very
Yeah.
soon.
Yeah. Thank you,
All right.
everybody. It's a pleasure, and all the best to you.
Thank you very much.